started talking about trigonometry. Yeah? And the thing about trigonometry was that we said it's got to do with right-angled triangles, and someone did a bit of research into right-angled triangles, and what did they find out? Did anyone want to explain what we were doing with trigonometry? So do you remember I started talking about trigonometry? I said someone looked into right-angled triangles, specifically right-angled triangles, and they found something. Yeah?
No matter how many times you break it down, it's still the same thing.
Yeah, part of it, wasn't it? If we consider this angle, it doesn't matter how many triangles you have, you can make smaller and smaller and smaller triangles. We keep the same angle, but what also stays the same? Yeah, and something else. What did I call them? So we ended up with, that's the angle.
The size.
What was it called? You do. So we ended up with SOHCAHTOA, but do you remember I said they were ratios, right? So these are the trigonometric ratios. Okay? And they are ratios because a ratio is another name for division. Okay? So a fraction is like a ratio. When you divide something by a ratio, you split it up. So what are the ratios that were looked at? Because they were the ratios of certain sides. And which sides were they? Opposite with? So opposite divided by hypotenuse was one ratio. Exactly. Adjacent divided by hypotenuse and opposite divided by adjacent. So we looked at those ratios, okay, and it was discovered, wasn't it, that those ratios stayed the same, yeah, if the angle stayed the same. So it didn't matter what size of triangle I was looking at, those ratios stayed the same. And we use that information. By the way, we've got all these notes, unless you really want to make these notes any further. We're kind of moving to something different. But this is what, so we related it to the angle. And we said, right, so the opposite over hypotenuse ratio was called?
Oh,
yeah, exactly. Sine of whatever angle we chose. The adjacent over the hypotenuse was the cosine of whatever angle we were using, and opposite over adjacent was the tangent. So we can use that information. All right, but that involves us having an angle. And if we have an angle and we know the sides, we can work on some sides, or one side, we can work out the other side. So just checking, this side is the, that one's the hypotenuse. This side is the opposite, and this side is the adjacent. Okay. So that's the trigonometry. We're using the angle to find missing sides. Or we can use the sides to find the angle. We've done all of that, right? Got your worksheet. I've got some homework for you as well on that, by the way, to help you prepare for the assessment. Now, there is another set of relationships with a right-angled triangle that doesn't include the angle. All right? So this does include the angle, but the thing that doesn't include the angle, someone discovered it. Do you know who discovered it?
Pythagoras?
You'd think so, wouldn't you? You'd think Mr. Pythagoras had discovered Pythagoras' theorem. I can't actually tell you who discovered it, but what happened, this is how history works, isn't it? I'm sure you've talked about history. Mr. Pythagoras, whoever he was just the person that wrote it down and explained it to people. It was already there. I don't think he actually discovered it because ancient Egyptians used it to build right angles in their pyramids and things like that. Okay? So it wasn't him, but he did claim it as his own by what was all important and still is. It's the person that publishes the work gets their name on it. All right. So if you ever discover anything, if you ever create anything new, make sure you get your name on it, because someone else will take it and put their name on it and get credit for it. So Pythagoras' theorem still looks at the sides of the triangle. Well, actually, yeah, it sort of does look at the sides, but what it does, whoever it was that discovered this relationship was not interested in the angles. They were interested in just looking at the relationship of the sides, nothing to do with angles. Okay? And what they discovered was, they probably did lots of research, but they discovered if you take a square, I'm going to have to look, right? If you draw a square, stop. It's not really a square, is it? But you get the idea. On shorter side, which is what you've got in your diagram. You take a square on the shorter side, and then you take a square on the other short side. Alright? And you take a square, so this is going to be hard for me to draw. If you take a square on the hypotenuse, you consider all of those squares. Alright? What we know, or what was found, is if you add the area of the two smaller squares, you get the area of the bigger square. Alright? So let's say this is area A, this is area B, and this is area C. So A plus B equals C. Alright?
Yes.
So that's what Pythagoras' theorem is about, actually. It's about the areas, the sizes of the squares that go on the sides of the triangle. So you will see on this sheet that I've given you, alright? It's quite hard to draw it, as you've seen. My C square is a rubbish square. Actually, none of them are squares. But you'll see on the diagram there that that's what has gone on. Right? Now, what we can do then, you see, is we can use those squares to find the lengths of the triangle that make the squares. Right? So if I label the triangle, I'm going to call this side A. This will be side A, this will be side B, this will be side C. Now, what is important is the square that's on the hypotenuse, the biggest square, we always label that one C. The other two, A and B, doesn't matter. So it's always got to be A plus B equals C. Alright? Now, if I find the areas and add them together to get C, right, how does the area of a square relate to the side that makes it, the side of the triangle? So yeah, if I know the area of this square, right, so let's have a look at the one. So we've got the one in your books, let's say that's 9 centimetres squared, this is 16 centimetres squared, this would be 25 centimetres squared. So that was what was found. If we did it, it was 9, 16, 25. How do we use those numbers to find the length of the square?
Okay, so maybe since we now we can find the
Okay, yeah, fine. So here's a square. So what I'm asking you for is, if I know that square is 25 centimetres squared, how do I know the dimensions of the square? Okay?
Or you could find that by 4. Well, to get the outside numbers.
Does that work?
No, that's not.
Why not then, if you say no?
They may not all be the same numbers at some point.
Well, they
Or not
must be the
that
same numbers, right? How do you find the area of a square? Length times width. Right? And what do you know about length and width of a square? They're the same. So it's something times itself, right?
Where? I'm just looking on the sheet. It's how many squares can go into that square with that amount of squares?
Yeah. So, if I know that the square, the area of a square is 25 centimetres squared, I think, like you've just said, it's length times width, but we know for a square that length and width are both the same, right? So you notice how on this triangle I've called it C. So I've written C there. Now as a square I know it's C and C, yeah? So how do I find the area? So it would be C times C equals 25. What's another way of writing C times C? C squared, that equals 25. Okay? So, if I look at this then, if I say Pythagoras' theorem is the area of A plus the area of B equals the area of C. Now I've already decided that this C, big C, related to little c, is little c squared. That's how I would find that area, yeah? What about the areas of A and B?
You do the same thing.
Same thing. So if little a, sorry, big A, area A, relates to A, so that's A, this is also A. So what's the area? How do I work it out? A times A, which is A squared. So same thing here, so that would be little a squared. So I've got A squared. Alright, tells me the area of A. Okay. And finally then, area B is done by B times B, which is B squared. So what I've done is I've taken these are the areas, and I've rewritten it, but using the lengths of the triangle. Okay? So a lot of people think Pythagoras' theorem is about the lengths of the triangle. Pythagoras' theorem is actually about the areas of the squares that go on the lengths of the triangle. Okay? And we can use the areas to find the lengths. Okay?
How do you find the area of the squares in the first place?
So when he was like that, so hang on, are you paying attention?
Yes, I am.
It's always like anything you can look at other than me and other than the work. It's like, where does you want to look? Right? You ever seen horses with blinkers?
Yes.
Right, get you some. Nice, stay focused. Right, good question. How did he do it? Now, what happened was, I think, how would you go about it? So, let's say you were given a right-angled triangle. How would you find the area of the squares on the right-angled triangle? What would you do, practicality-wise? So you have a square, and you would measure it, and then multiply the sides, and that would tell you the area. So that's what they did. They took a right-angled triangle, any right-angled triangle, they measured the sides of the big one and the two smaller ones. They calculated the area, because they already knew how to find the area of the squares. They just hadn't related it to triangles yet. Okay? So, for instance, let's have a look at the question that's sort of there on the sheet. Okay? So, hopefully this will help. So what we can do then is we take a triangle that has got what dimensions?
4.
It's on the sheet.
2.
On the sheet.
6.
5, 13.
Thank you. 5, 13 and 12. Okay? So what we're doing is we're doing what they would have done. So they've drawn a right angled triangle. Alright? Drawn a right angled triangle like this. They know the lengths, so they know that one length is 5, one length is 12, and one length is 13. They've measured it. Alright? Now, Pythagorean theorem states that if I call that square A, this one will be a bigger square, but I'll call it square B. This one will be square C. Right? So we know that Pythagoras' theorem is A plus B equals C, the areas. But what is the area of A? It's not 5, it's 25, because we do 5 squared. So we're saying 5 squared plus, not 144 squared, 12 squared, yeah? 12 squared should equal 13 squared, if we're correct. And does it? Well, 5 squared is 25. 12 squared is 13 squared is 169. It's on the wall. Right? Now the check is, does 25 add 144 equal 169?
Yes.
It does. So we know that that's a right angle triangle. We know Pythagoras' theorem works. Now most of the time then what you'll see on that worksheet that Pythagoras' theorem states, alright, and this is what you'll have in your notes. The Pythagorean theorem is written as a squared plus b squared equals c squared, where if we have a right angled triangle, this side is, which is labelled as
C.
C, thank you. It is the hypotenuse, but we label it as C. This side and this side are A and B. So that's the Pythagorean theorem, and we can use this information to solve for our triangles. Okay? So, I've got a worksheet for